Bismillahirrahmanirrahim. Welcome everyone. Today, inshallah, I'm going to talk about isomer for AS students in Cambridge Assessment, Oxford UKI, and Pearson in Excel. So this information very important for students in AS chemistry. As you know from O-level, isomers are compounds with the same molecular formula but different structure. In O-level, we asked you to just draw different structure for particular compound. It's okay. For example, but 1-ene, you have to draw but 2-ene. Just change the position of the double bond. But today in AS, we have a new kinds of isomer, a new naming. One of them is cis-trans isomer. Number 2, entgegen-Zusammen isomer or EZ isomer. EZ isomer. So let's start with cis-trans isomer. For example, what is the cis-trans isomer for C2H2Cl2? In this example, I can draw the two compounds like this. In the first one, on the left side, this is carbon connected with chlorine and hydrogen. Even this carbon, the second carbon, connected with chlorine and hydrogen. What you noticed here? The chlorine here, which connected with the carbon on the right, up. The chlorine here, which connected with the carbon on the left, it's drawing up as well. So both in the same direction. Both in the same direction. Even down here, I have hydrogen, and down here, I have hydrogen. Hydrogens are in the same direction. So two chlorines up, two hydrogen down. This is called cis. Cis. It's okay? Cis isomer. And you have to write the name of isomer without any change. But which kind of isomer this? This is cis. Why cis? Because chlorine and the chlorine on the same direction, hydrogen and the hydrogen on the same direction. So this is cis isomer, cis isomer. In this compound, you have chlorine and hydrogen in the first carbon, and chlorine and the hydrogen in the second carbon. But what is the difference? What is the difference? In the first carbon, you can see chlorine attached to the carbon on the right, up, and chlorine attached to the carbon on the left, down. One chlorine up, one chlorine down. So opposite direction. Even hydrogen here down, and hydrogen here up. So opposite direction. Once the same connection in opposite direction, this is called trans isomer. Trans isomer. So I can summarize what I said today. In cis isomer, the substitution with carbon on the same direction. Chlorine up, chlorine up. Hydrogen down, hydrogen down. So this is cis isomer. But in trans isomer, in opposite direction, chlorine up and chlorine down. But here hydrogen down and here hydrogen up. So this is trans isomer. Another example about cis and trans. You can see here, of course, you know, this line means I have carbon here and I have carbon here. But in AS, you have ability to draw without writing a carbon. Hydrogen down, hydrogen down. CH3 up, CH3 up. So this is cis isomer. Cis isomer. Okay? And for this, hydrogen up, hydrogen down. Oh my God, this is opposite direction. CH3 down, CH3 up. Oh, opposite direction. So this is a trans isomer. Trans isomer. So if I ask you, is this isomer cis or trans? I don't know. What you have to do, you have to check. Oh, hydrogen and hydrogen drawing down, CH3 and CH3 drawing up. So this is cis isomer. But here, hydrogen up and hydrogen down, CH3 down and CH3 up, opposite direction. So this is trans isomer, trans isomer. It's okay. But in cis and trans isomer, the substitution with the first carbon must be the same as the substitution in second carbon. What does it mean? Here I have hydrogen and CH3. Even in the second carbon, I have hydrogen and CH3. In this case, I can say one of them is cis, one of them trans. Even here, this example, you can see here CH2, CH3, and H. CH3, CH2, and H. Isn't it? So here, hydrogen and hydrogen down, drawing down, and CH2, CH3, CH2, CH3 drawing up. So this is what? Which one is cis? Which one is trans? This one is supposed to be cis. This is cis, not a trans. Why? Because hydrogen is down and the hydrogen here is down. CH3 is up and the CH3 is up. Okay? In the second one, hydrogen up, but here hydrogen down. So this is cis, and this is trans isomer, because the connection of hydrogen in the first carbon drawing up, hydrogen in the second carbon drawing down. So this is a trans, but here H down and H down, so this is cis. You can say this is cis isomer. Now, I said in cis and trans isomer, the substitutions must be the same. H and the CH3, H and the CH3 in the second carbon, I mean. But what if you have substitution like this? Like this one. Look. In the first carbon, H and the Cl. In the second carbon, Br and the F. So different substitutions. I cannot say cis and trans, so that we have another system which known as EZ isomer. EZ isomer. E means entgegen. Z means zusammen. This is a German language. As you see here, the isomer with the same priority, we will understand what is the meaning of priority. On the same side of the double bond, this is known as Z. Z means zusammen. Zusammen in German language, it means same. Okay? So zusammen, it means same. Put it in your mind. Zusammen means same, but entgegen means opposite. What is the same? What is opposite? To check this example. In the first example, I can use cis and trans numerical system. I can use cis and trans system. Why? Because in the first carbon, I have H and Cl. In the second carbon, I have H and Cl as well. Okay? Even here, I can use cis and trans. Why I can use cis and trans? Because in the first carbon, I have chlorine and hydrogen, and in the second carbon, I have chlorine and hydrogen as well. So I can use cis and trans system. It's okay? But what about the second example, which you can see down here? You have to look to this example. What is the difference between this example and the example above? Okay, what is the difference? What do you think? Take a moment. What is the difference? Yes, exactly. Here, the same substitution in both carbons. The same substitutions in both carbons. But here, in the first carbon, I have H and Cl. But in the second carbon, I have Br and F. So different, isn't it? It's okay. So this is the difference. I cannot use cis and trans. I will use EZ system. What is E? We said Z means zooxanthellae. Z means zooxanthellae. Zooxanthellae, it means the same direction. But E entgegen, it means opposite. What is opposite? What is the same? Here in EZ system, we are talking about priority. Priority. What is priority? Look to the first carbon. The first carbon attached with hydrogen and chlorine. What is the mass or what is the atomic number of each one? Atomic number of chlorine is 17. Atomic number of hydrogen is 1. Which one is higher? 17 or 1? Of course, 17. So chlorine has a higher priority, This is priority number 1 because it has higher atomic number. Hydrogen, priority number 2. What about F and bromine? In F and bromine, what is the atomic number of each one? By the way, you can find atomic number in the periodic table. Bromine is 35. Atomic number 35. Fluorine is 9. So which one has a higher priority? What do you think? Higher priority, I mean higher atomic number. Of course, bromine here, 35. Fluorine is 9. Bromine is the higher priority. Priority of bromine is 1, but priority of fluorine is 2. Isn't it? So you can erase these numbers, the atomic number, you can erase these atomic numbers. Okay. Now look to the priority. Chlorine in the first carbon. Chlorine has a higher priority attached to the carbon down. And here in the second carbon, this carbon, bromine has a higher priority attached with the carbon but up. So what do you think? Is it opposite or the same? Opposite. Why? Because the higher priority here is down, but the higher priority here is up. So I can say this is E isomer, entgegen isomer. What about the second one? Again, I will repeat what I said. In the first carbon, I have chlorine and hydrogen. Atomic number of chlorine is 17. Atomic number of hydrogen is 1. Which one has a higher priority? Of course, chlorine. Chlorine, higher priority. And after that, hydrogen. In the second carbon, bromine. Atomic number of bromine is 35. Atomic number of fluorine is 9. So which one has a higher priority? Of course, bromine, because 35 higher than 9, more than 9. So bromine has a higher priority than fluorine. What do you think now? In the first carbon, the higher priority attached up, and in the second carbon, the higher priority attached up as well. So in the same direction. The higher priority here is up, the higher priority here is up, so this is zooxanthellae. But it's enough to write this is Z isomer. It's okay? So I can summarize my word to say In this example, I can use cis and trans because in the same carbon, I have the same substitutions, HCl and here HCl. HCl, HCl, the same substitutions. But here in the second example, I cannot use cis and trans because in the same carbon, I don't have the same substitutions. In the first carbon, there is hydrogen and chlorine. In the second carbon, there is bromine and fluorine. So the four different substitutions are different. So what should I use? EZ system. EZ system. What is EZ? Z means zusammen. Zusammen, it means the same. E means entgegen. Entgegen means opposite. What is the same? What is opposite? We are talking about priority. How can you find priority? From the atomic number. Atomic number of chlorine is 17. Atomic number of hydrogen is 1. So chlorine has a higher priority. With the first carbon, chlorine has a higher priority. With the second carbon, this carbon, bromine 35, fluorine 9. So bromine has a higher priority. As you see here, higher priority up in the second carbon, higher priority down. So this is entgegen isomer. In this example, hydrogen and chlorine. Which one has a higher priority? Of course, chlorine, because chlorine is 35. In the second carbon, bromine and fluorine. Which one has a higher priority? Of course, bromine, because bromine, here, chlorine, 35.5. Sorry, chlorine here, 17. Mass atomic number of chlorine is 17, more than hydrogen, which is 1. So chlorine has a higher priority. In the second carbon, I have bromine and fluorine. Bromine is a higher priority because bromine is 35. The higher priority up, the higher priority up. So this is zusammen isomer. Zusammen isomer. As you see here, higher priority down, here higher priority is up. So opposite direction, it means E isomer. But here, chlorine is the higher priority up, bromine is the higher priority up. So this is zusammen. We can say if the two groups with the higher priority are on the same side or on the same side, chlorine higher priority, bromine higher priority on the same side of the double bond. So this is described as Z isomer. Z means zusammen. Zusammen means the same. The same what? The same side. But here, opposite side. So this is entgegen. In this example, of course, you can use here CH3 and H, here H and CH3. So as you see, this is a trans. This is what? Trans. Here, more complicated example, just to check. Can I use cis trans isomer? Just to check. In the first carbon, COOH, CHO, NH2CN. So 4 different substitutions. I cannot use cis and trans, so I will use zusammen isomer and entgegen isomer. Zusammen means the higher priority on the same direction. Entgegen means the higher priority in opposite direction. In the first carbon, connected with carbon here, COOH, I will count the first carbon. And this carbon connected with carbon here. So the same priority. Here carbon and here carbon. The same priority. Check the next element. Here oxygen, but here hydrogen. Atomic number of oxygen is 8, but atomic number of hydrogen is 1. So this is higher priority. This is higher priority. So I will check atom by atom. Atom by atom. This carbon and this carbon, the same priority. O and H, which one has a higher priority? Oxygen. So this is higher priority. This is number one. This is number two. What about the substitutions here? It's okay. Here connected with N and here connected with N. By the way, this is NC. NC. N and N, so the same priority. After that, you have here H. But here you have C. Of course, carbon is 6, but hydrogen is 1. So this is the higher priority. As you see, the higher priority in opposite direction. One of them is up, and in this carbon, the higher priority is down. So this is entgegen isomer or E isomer. In the second example, is to check again. In the first carbon, I will check the first carbon. Connected with C here, and connected with C here. So the same priority. Check the next element. Here is hydrogen, atomic number 1. Here is oxygen, atomic number 8. So this is the higher priority. This is the higher priority. Why? Because atomic number of oxygen is 8, higher than atomic number of hydrogen, which is 1. Let's check the next carbon. This carbon connected here with NH2 and here with NC. Connected with N and connected with N, the same priority. Here, after that, I have H and I have here C. But the atomic number of carbon is 6. Atomic number of carbon is 6, higher than hydrogen. So this is priority number 1. As you see, the higher priority in the same direction. So this is zusammen isomer or Z isomer. Z isomer. We can summarize what we said today. If you have the same substitutions in both carbon, you can use cis and trans. But if you have 4 different substitutions, you have to check if the same priority on the same direction of the higher priority on the same direction. So this is zusammen isomer. But if the higher priority in opposite direction, so this is entgegen isomer or E isomer. For more information, follow our Facebook page, IGCSE Chemistry Mohammed Bizaid, and our YouTube channel. Thank you for listening, for attendance. Assalamu alaikum wa rahmatullahi wa barakatuh.